Today we're going to be looking at the distance formula and the midpoint formula. You'll see in just a moment why the distance formula comes to us courtesy of the Pythagorean theorem. They are directly related. They are basically the same thing, except one uses A and B and one uses coordinates. For example, what is the length of segment AB if point A is at 4, 1 and point B is located at 10, 9? So here I have two endpoints and I want to know what the distance or the length between them is. So my first step would be to graph these. So here point A was at 4, 1 and point B I've graphed at 10, 9. In a coordinate plane, I can't just count the number of places diagonally because I'm not going to have, this is not the same as one unit. I can only count units horizontally or vertically. So when I'm dealing with diagonals, I can't just count units to figure out how long something is. So I have to be a little bit creative. If I look at this is a diagonal, and I want to think, well, what happens if I had these two sides meet each other? And what kind of shape did I just create here? And you should notice that this becomes a right triangle. And if I know the sides of this right triangle, I can easily determine the distance here, the length of this segment, by using the Pythagorean theorem, which is a squared plus b squared equals c squared. In our triangle here, c squared is the distance I'm looking for. I'm looking for the hypotenuse. Because this is a horizontal distance, I can count how many units make up this side. So this side is 1, 2, 3, 4, 5, 6 units long. So let's say this is side A. So the length of side A is 6. Let's see what the length of side B is. 1, 2, 3, 4, 5, 6, 7, 8. Well, if I know that A is 6 and B is 8 and this is a right triangle, I can plug these numbers into the Pythagorean theorem and solve for the length of C. So let's do that now. If A is 6, I have 6 squared plus B is 8, 8 squared. That will give me C squared. 6 squared is 36, 8 squared is 64. This gives me C squared. 36 plus 64 is 100. Is c squared. Now, many people make the mistake of stopping here, but notice that we have not solved for the side c. We have solved for c squared. Our final step needs to be the square root of both sides. So 10 is the length of c. So how can I use something, a distance formula, that does not involve me having to draw this triangle out? And what I want to do is draw your attention to our sides A and B. So if we look at side A, we got this by counting a horizontal distance. Well, which coordinates deal with horizontals? Is it the x or the y values? And it's the x values. Okay, horizontal is the x-axis. So let's look at our x values in each one of our coordinates. What relationship do you see between the 10, the 4? How do we get 6 from that? You notice that if we subtract 4 from 10, we get this distance. Same thing with our y values. Y's are our vertical, so the vertical side of our right triangle is going to be this y value minus this y value, 8. So really what we've done in the Pythagorean theorem to find side A, we did this x minus this x. That's how we got 6, and then we squared it. To find B, we did this y minus this y. That gives us this distance, and we squared it. And then we did the square root of the entire thing. That is the distance formula. When you are given coordinates, if you need to replace A and B, A are the x values subtracted, and then we square. B are the y values subtracted, and then your final step, the distance, or c, is the entire thing. You take the square root. This is a shortcut so you do not have to keep drawing right triangles on your graph paper, and sometimes you will not have graph paper. So it's critical that you understand and know this formula so that when you are given only coordinates, you can find the distance or the length of any segment. So let's see what this looks like in application. So our problem says find the length of each segment AC and then CB. So to find, I can't just count because these are both diagonals, so I need to use the distance formula. So for AB, segment AB, its coordinates, A is at -3, 8, and C is at 0, 2. I also need to know B eventually. Let's go ahead and do it. It's at 6 and then up 5. Okay, so we want to find the distance or the length of AC. My distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. I'm subtracting the x's, squaring it, subtracting the y's, squaring it, and then doing the square root. So if we plug in our numbers, we have 0 minus -3 squared, and then 2 minus 8 squared. Square root of 0 minus -3 is 0 plus 3, so 3 squared, plus 2 minus 8 is -6 squared. We square this because we want to get rid of any negative numbers that are over here. So, square root 3 squared is 9, -6 squared is -6 times -6, positive 36. Then when I add these together, 9 plus 36 is 45. I want us to be comfortable working with radicals, so rather than doing a decimal of this, let's simplify under the radical. Remember, we do this by doing the prime factorization. So 45 is 3 times 15. 15 is 3 times 5. Any duplicates, so I have a pair of 3's, they come to the outside. What's left under the radical is 5. So the length of segment AB is 3 square roots of 5. Let's do the same thing for segment CB. So we're going to use our same distance formula. It's here, so I won't rewrite it, but I do want to write what I'm plugging in. So for x2, let's use 6. And it doesn't matter which order you do this in, whether this is x1 or this is x1. What matters is that if I use this as my x1, I have to use this as y1. So the order you have to keep it consistent. This is one coordinate, this is the other coordinate. So 6 minus 0 squared plus 5 minus 2 squared. Square root this. 6 minus 0 is 6. 5 minus 2 is 3. Looks like we're going to end up with the same thing. 6 squared is 36. 3 squared is 9. I have square root of 45, which I can double check. These have the same length, therefore they are congruent. Square roots of 5. So AB and CB were congruent segments. Let's do this again, and for time's sake, let's not do all of these. Let's just look, for example, let's do segment AC. Okay, so we're looking at this and this. If I want the length and I'm given coordinates, I'll use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. Okay, let's say these are our x2, y2. So 3 minus -4, square that, -2 minus 7 squared. -3 minus -4 is plus positive, so I have 7 squared plus -2 minus 7 is -2 plus -7, so -9 squared. Here I have 7 squared, which is 49. Here I have negative 9 squared, which is 81. When I do the square root, if I add these together, I have 130. Okay, so my distance is 130. Again, I want us to be comfortable with radicals, so let's see if we can do the prime factorization to see if we can simplify this radical. So if we have square root of 130, that's 13 times 10. 10 is 2 times 5. So there are no duplicates that I can pull out, so this is in simplest form. So our distance is the square root of 130. Here's a problem where we have to do a triangle. It says, what type of triangle has these endpoints? When we're dealing with types of triangles and we're dealing with distances, we're most likely going to look to see if any of the sides are the same length. So to do that, I need to do the distance between each side. So let's say this is A, B, and C. Okay, these are our coordinates. So I need to figure out the distance of AB, the distance of BC, and the distance of AC. Those would be the three sides of my triangle. So let's see if we can do these really quickly. x2 minus x1 squared plus y2 minus y1 squared. So we're going to go ahead and plug in. Let's look at AB first. So let's do negative 2 minus negative 5 squared plus negative 3 minus negative 1 squared. Okay? We have square root of 3 squared plus negative 3 minus a negative 1 is plus positive, so negative 2 squared, square root of 9 plus 4, square root of 13. 13 is a prime number, so this length is the square root of 13. All right, let's look at BC. So we're going to use our distance formula again up here, except now we're looking at BC. So C we're going to use as x2, negative 5 minus negative 2 squared plus negative 4 minus negative 3 squared. Negative 5 minus negative 2 is plus positive 2, negative 3 squared plus, here we're going to have negative 4 plus positive 3. So we have 1 squared, square root of 9 plus 1, square root of 10. So this is the square root of 10. Lastly, we need to look at AC to see if we know we don't have an equilateral triangle. We may have an isosceles triangle, so we have to keep going. Lastly, we're going to fill in. Let's look at C and A. So negative 5 minus negative 5 squared plus negative 4 minus negative 1 squared. Plus a positive, well that's 0. 4 minus negative 1 is 4 plus positive 1, which is negative 3 squared. So I have the square root of 0 plus 9, square root of 9, which is 3. None of my side lengths are the same. What type of triangle would this be classified as? This is a scalene triangle. So now briefly I want to look at the midpoint formula. Sometimes we're asked what is the midpoint of a segment with these endpoints, so negative 2, 5, and 2, 2. Okay? This formula is actually a lot easier than the distance formula. Because think about, how would you find the midpoint of a segment that's 10 inches long? Well, you're going to take that segment and divide it by 2. Its midpoint is at 5. You're going to do basically the same thing here, except now, instead of having one number that you're dividing by 2, you need to find the average of the x values. So you're going to add them and divide by 2. And you need to find the average of the y values. So add them and divide by 2. And that will give you the x and y of your coordinate. Okay? So what we're doing here, if we want to find the midpoint, which needs to be a coordinate, something, comma, something. To find the x values, I add the x values of each coordinate. So negative 2 plus 2 over 2. So I have, these are my x values. So negative, that's 0 over 2, so 0. So my midpoint, the x value is 0. Do the same thing with y. 5 plus 2 over 2, 7 over 2. So I end up with y of 3.5. I put them together, and so my midpoint coordinate is 0, 3.5. So here's an application problem where it says R is the midpoint of P and S. Okay, so PR and RS are the same length. Q is the midpoint of RS, so these two are the same. P is located at 8, 10. S is located at 12, negative 6. What are the coordinates of Q? Okay, well my first step, I need to figure out what R is. So R is the midpoint of these two. Midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. I'm just adding and dividing by 2. So to find R, I'm going to do 8 plus 12 over 2 and 10 plus negative 6 over 2. Okay, 8 plus 12 is 20, divided by 2 is 10. 10 plus negative 6 is 4 over 2, which is 2. So R is at 10, 2. Now to find Q, Q is the midpoint of these two. So I'll repeat this formula with these coordinates. So I will do 10 plus 12, my x values, divided by 2. My y values, 2 plus negative 6 over 2. 10 plus 12 is 22. 22 divided by 2 is 11. 2 plus negative 6 is negative 4. Negative 4 over 2 is negative 2. Q is located at the point 11, negative 2. And that's all I have for you. You do need to know the distance formula and the midpoint formula, and when it's appropriate to use these, you need to know how the distance formula is related to the Pythagorean theorem. So these are things that you'll need to be studying. You will have a quiz on these. So good luck studying, and I will see you later.